And today is Friday and it's the last lesson. Today is the 9th. Okay, so applications of trig. Is what we're going to be busy with, i.e. word sums, i.e. finding heights and distances in context. So if we're going to talk about heights and distances in context with word sums, I'm going to talk about stuff like the height of a building, or how far is it to the tree, or I'm looking from one building to a taller building. Anything that I can draw a right-angled triangle with in a word sum is what I'm going to be doing. But in order to do that, there are two terms that we have to familiarize ourselves with. And that is the angle of elevation or inclination. I just want to see which term they use. Is it elevation or inclination? I think it's inclination. Elevation and depression. Okay, so an angle of elevation What does that mean? It is the angle between the ground and something I look up at. Oops, up at. Not, yeah. So, I mean, that's what elevate means, right, is to rise. So if I had to draw a picture, I'm standing here. So it would be the angle of, let's make a tower. I can't draw. I'm very bad at drawings. Okay, that's supposed to be a tower, even though it looks like a pencil. Okay, so from the ground, looking up at the top of the tower would be my angle of elevation. I can also look down at something, can't I? If I'm on top of the building and I'm looking down, I call that the angle of depression. Depress or get smaller, angle of depression. So it's the angle in line with me looking down. So if I had to draw an angle of depression, I, for instance, would stand on top of a balcony and I would look down at the car below. Definitely cannot a car. I don't know. Some funky thing. I'm sorry. So it's the angle in line with me and the thing. So starting in line with me and the angle that it makes to get to that thing. So can you see how I have formed right-angled triangles? Here's my right-angled triangle with my right angle there. And I've also formed a right angle triangle here with my right angle over there. So since I can form right angle triangles, that means I'm going to be able to use trig. Now there's one other thing that I want you to note. That the angle of elevation and the angle of depression to the same viewpoint would be the same. So I'm going to have to draw another picture to show that. So I'm just going to stick to very standard blocks because my pictures are obviously not very artistic. I can draw a flower, let's say a flower. Okay, anyone still drawing with this first drawing? Okay, moving the first drawing out of the way so you can just see the angle of depression. Okay, so here I'm standing on top of a building looking at my flower. Okay, if I'm looking down at my flower, here's my angle of depression. That matches my definition, right? From in line from where I am to looking down at the item. But what if I am the flower, looking up at the person? What would that angle be? Angle of elevation. What can you say about those two angles when I'm referring to the two same starting and ending points? Almost opposite. I know what you're trying to get to. So the two lines are parallel. What does it tell me about those two angles? They have to be the same. So in a case where I'm referring to the same start and end points,
what does it say? Does it say lot or is it angle of elevation?
Angle of, yeah. Angle of elevation, angle of depression. In the case where I have created parallel lines as above, my angle of depression will equal my angle of elevation. So, like I have above, I'm trying to get both of this, I can't get it all in the same thing. Okay, there. In the case where I have created parallel lines as above, my angle of depression must equal my angle of elevation. And if I had to give a reason for that, I would say alternate angles are equal. So we'll start with a basic one, then we're going to move on to a more complicated one, and then a very complicated one. So when it comes to these questions, I can ask you for the distance between the bottom of the building and the flower. I can ask you for the height of the building. Or I can ask you for the angle itself, but it will obviously depend on what information I give you. So let's look at an example. The height of your kite on 15 meters of string flown at 52 degrees. So I want to know the height of your kite above the floor. So let's do an example. Anyone still busy? Okay. So let me just take that one out of the way. I'll leave that one for a little bit. So my first example, example 1, what is the height of my kite above the ground if it is on a string of 15 meters and is flown at an angle of 52 degrees. Would that 52 degrees be an angle of depression or an angle of elevation? Elevation. I'm looking up at my kite in the sky, right? So if I stand here, here's my kite, and it is on 15 meters of string at 52 degrees. I'll show you the picture now. I want to know my height. Okay, I'm going to have to go up now. So there's my kite at an inclination. I keep saying inclination. I mean elevation. It means the same thing. I'm very sorry. Elevation of 52 degrees on a 15-meter string. What is my height? Pardon? My string is 15 meters. If this is forming a 90-degree triangle, which side is my 15 meters? It's my hypotenuse, right? What is the height of my kite in relation to my 52 degrees? Opposite over hypotenuse. Fantastic. So it would be sine 52 degrees is equal to my height, which is my opposite, so that's actually a bit misleading. Height over my 15 meters.
So now is your height the opposite?
Is my opposite, exactly. Opposite adjacent to my reference angle. So how am I actually going to solve for height? Height equals what? Sine 52 times 15. Fantastic. So let's calculate. It's definitely going to need our calculators. Sine 52 degrees, close that bracket. Remember I told you yesterday, big boo-boo if you don't. Times 15. Tells me that it is 11,82 meters off the ground. Or is at a height of 11,82 meters. Not so bad, right? I hope. We'll do one more. Okay, let's do this one. From the top of a lighthouse, so my second example, from the top of a lighthouse, the angle of depression to a yacht. So let's move that up a bit. So from the top of a lighthouse, the angle of depression to a yacht is 19 degrees. The lighthouse is 24 meters high. How far away is the yacht? How far away is the yacht from the base of the lighthouse? So there's my word sum. From the top of a lighthouse, the angle of depression to a yacht is 19 degrees. The lighthouse is 24 meters high. How far is the yacht from the base of the lighthouse? So draw yourself a little picture. There's my lighthouse with a light, I guess. Here's my little yacht. My angle of depression, so remember it is in line with going to. So here is my angle of depression. 19 degrees. My lighthouse is 24 meters high. And am I asking for the length of the lighthouse top to the yacht? Or am I asking for the length from the bottom of the lighthouse to the yacht? The bottom, because I say the base of the lighthouse. So this is what I'm trying to find. Yes, Dred? Okay, alternate angles because this is parallel to that. Could have also done that, for sure. So you could have either said, okay, I know that that's my depression, and therefore this is the same as my elevation, and use that as your reference angle. Or you could have done the second thing Jed said, well, I know that this must add up to 90 degrees, therefore this would be 61 degrees, and use the 61 degrees as your angle of reference. I am going to tell you it is more conventional to change it to the angle of elevation rather than the complementary angle. Okay? So now we can do it. What is this in relation to my angle? Adjacent. What do I have? So which function am I forced to use? Tan. So tan of 19 degrees. And if you need to do the first step, then do it. What is opposite? It is 24. What am I looking for? It is my adjacent. Pardon? 19. I wrote 15, yeah. Sorry. You must be awake. So now I want to find my question mark. So what am I going to do? Essentially, I'm going to divide. So remember, I'm essentially swapping those two around. Because tan 19 is equal to 24 over my adjacent. We'll leave it as adjacent. I want adjacent by itself, so I'm going to take it over and times. But then I have A, my adjacent, times 19 degrees equals to 24. but I want A by itself. So now I'm going to divide. That just cancels, so I'm left with A is equal to 24 divided by tan 19 degrees. Essentially, Erin, we swap the A and the tan around. So we go to my calculator, type it in, close that bracket. I'm also going to get an error. Tan 19, close the bracket, giving me 69.70 meters away. And if we wanted to round off to the nearest meter, what's my nearest meter? 70 meters away. So I would actually, in a test, make sure that I know it is alternate angles equal that I used. Alternate angles equal, and I used parallel lines. I don't have names for it, but I know that there are parallel lines there. Yes, Jed? Yes, you may, Jed. Let's do another one like this, and then we are going to do quite one that's slightly more difficult. Can I take this off, grade 10s? I see Daniel's still writing, Alex is still writing. Okay, I'll draw the next one so long. Okay, let's do that one. I'm actually going to bring it from the textbook. It's finished. Are you still busy, Alex? How far are you? Where are you?
Are you going to place it?
No, I'm going to show it under the document camera. Is it only Alex still drawing? Right, and you done? And then take this for me. Okay, I'm going to show it from the book. So I'm going to zoom into the book. So I'm adding two triangles into one scenario. So I'm going to zoom in quickly. Okay, so I have, from the top of a building, the angle of elevation to the top of the tower is 75 degrees. Let's cover that for now. The angle of depression to the foot of the tower is 42 degrees. If the distance between the tower and the building is 50 meters, calculate the height of the building and the height of the tower. So since we have an angle of elevation to a tower, that means my tower has to be taller than my building. And my angle of depression from my tower to the, from my building to the foot of my tower, that means it has to go down. So visually, this is what we get. This is the top of my building. Here at B. Top of my tower, we have named it A, because sometimes it's easier to have the letters. So we can see they're from in line with, so in this case it would be the bottom part. Looking up, my angle of inclination or angle of elevation is 75 degrees. And looking down, I have an angle of inclination of, depression of 42 degrees. So they want the height of my building. So am I going to use this upper triangle to get the height of my building? If I looked at that upper triangle, what information would that give me? It would give me more information about the tower than anything else, right? So in order to do the height of my building, I know that they are 50 meters apart. I have an angle of depression at 42, and I want the height of my building. So if I had to draw that as a triangle, Angle of depression, 42 degrees. I'll show you now. 50 meters. And I want the height of my building. So I'm only drawing the triangle that I need to focus on. Otherwise, I'm going to be confused by everything else. So I know that this and that is parallel. So what can I say about this angle here? That's 42 degrees. So I'm going to use the letters that they use so that we can actually start writing some stuff down here. That's B, C, and D. So I will say that BCE is equal to 42 degrees. Why is it equal? Well, alternate angles are equal. BD parallel to EC. I have 42 degrees as my reference angle. 50 meters in relation to that angle is what? Adjacent to it. My height of my building in relation to my angle is opposite. So what function am I using? I'm going to use tan again. So tan of my 42 degrees is equal to my opposite, which is x, over my adjacent, which is 50. Now I need to solve for x. What am I going to do? Remember to close that bracket and calculate on your calculator. Tan 42, close the bracket, times 50. Telling me that the building is 45,02 meters high. My next question is asking me for the height of the tower. So let's go back to my diagram that shows everything. So now I have, grade 10s, I have this BE height. Do you agree with me that that is the same as the DC height? So we already found a portion of the tower. So if we can find the AD height, we can find the full tower by adding that last bit, can't we? So if I use just that triangle, won't that give me the missing part that I need? So let's do it. I have my 75 degrees, I have 50 here, I want AD. Which function am I going to use? I have the 50, I want AD. Which function uses those two sides? Are you sure? Why would it be cos? We have the adjacent side, but what do we want? So how can that be cos? It has to be tan again. So let's go look at that. Let's write it down. We have an angle tan 75 degrees is equal to my opposite, which is the AD, over adjacent, which is BD. But we know what BD is. It's just 75 meters. Not 75, 50 meters. Solving for AD, once again, we are going to multiply. Close that bracket because I just almost didn't. Telling me that it's 186,60 meters. So now I know AD and I know DC, so what's the full height of my tower? Therefore, full height is equal to 45,02 plus 186,60. my full tower height is 231.62 meters. Yes. Yes, you may. We still have 15 minutes. There's still another one where I want to make it even more complicated. Anyone still busy? Okay, taking it out. So I'm going to draw triangle first and then write this word sum down. Okay, so it's quite a few questions. We'll work through all of them. So Erin stands on a balcony. She is 5 meters above the ground. Zora is standing 15 meters away from Hannah in line with the bottom of the building. The angle of depression from Erin to Hannah is 20 degrees. Calculate the size of EHZ. Calculate how far Hannah is from the building. Calculate how far Zora is from the building. If Erin threw a shoe at Zora, what distance would it travel? And if Zora wanted to throw it back at Erin, what angle would she have to throw the shoe at? So those are our 5 questions that we are going to work through. If we don't finish, I will write it down and send the answers on the group. Okay? So let's start. You can get all the stuff on the group. I will take a picture. Okay? So first and foremost, let's fill in the information that we have. So I've already given you the picture showing you how they relate to each other. But I have given you an information about how high Erin is off of the ground and the angle of depression from Erin to Hannah. Okay? So using the letters, where would I put the 5? The 5 meters. Not by Hannah, by OE, because this is the top of my balcony, that's the bottom of my building, so this would be 5 meters. Then my angle of depression from Erin to Hannah is 20 degrees. So now I'm looking at a depression, right? Which means I'm starting at Erin, and Erin to the line that matches Hannah is 20 degrees. Everyone fine with that? We have put all our information on this picture. What we also know is that EOZ is a right angle and EOH is a right angle. The other thing we've been told is that from Zora to Hannah it is 15 meters. Where am I going to put that? ZH. My first question, what is the size of EHZ? 20 degrees, what's my reason? Alternate angles are equal, we have parallel lines. Perfect. That's already 2 marks. 1 mark, sorry, 1 mark. So this was a 1 mark question. This is a 3 marker. 1 mark. 3 marks. 2 marks. Okay. So we know that it would be EHZ is 20 degrees. I have to give a reason, both for 1 mark. We have parallel lines. And I can just say parallel lines even though I don't know what those parallel lines are. My next question asks, calculate how far Hannah is from the building.
Attention please, the following menus may now be dismissed. Downstairs B and C wing may now be dismissed.
So we now know that this is 20 meters. We want to know essentially what OH is, right? So there's my angle of reference. There's the information that I have. There's the information that I want. Which function am I forced to use? I want OH, which is what in relation to 20 degrees? Adjacent. I have 5, which is which kind of relation? So which function? Tan. So tan of 20 degrees is equal to opposite, which is OE, over adjacent, which is OH. But OE is equal to what? 5. OH is what I'm trying to calculate. So how am I going to find OH? I'm going to divide. OH is equal to 5 divided by tan 20 degrees. I am apologizing, but we are going to use our full 3 minutes. Closing that bracket. So Hannah is
Upstairs A and C wing, as well as the Hayward Center, may now be dismissed.
Yeah, we dismissed last. Okay, make that 5 meters, else it's not going to make any sense. So Hannah is 13,73 meters away, 74 meters away from the building. 13,74 meters away from the building. My next question is, how far is Zora from the building? Well, we know that OH is equal to OZ plus ZH, don't we? We know that that full distance can be broken up as to how far Zora is and how far Zora is from Hannah. So if the full distance is 13,74 and Zora to Hannah is 5, how am I going to calculate Zora to the building? There we go, 13.74 minus 5. So OH is 13.74. OZ is what we want. ZH is 5. So Zora to the building would be minus 8,74 meters from the building. Number 4.
Upstairs B wing may now be dismissed.
We'll leave very shortly. If Erin threw a shoe at Zora, what distance would it travel? So we now know that this is 8,74 meters. We have 5 meters. I have, can't calculate that. Because it was 15 meters, but the full length was only 13 meters, so it couldn't be 15 meters. Okay, I'm going to change. If Erin threw a shoe, can't be to Zora. Why can't I calculate the distance to Zora? Oh, I could, right? I could use Pythagoras, couldn't I? So let's use Pythagoras. So I would say EZ is equal to the square root of 5 squared plus 8,74 squared. Erin's shoe would travel how many meters? Erin's shoe is going to travel 10,07 meters. And I just did Pythagoras. And my very last question, grade 10s, I ask here, if Zora wanted to throw it back at Erin, what angle would she have to throw at? So what am I trying to find? I'm trying to find this angle of elevation. So I have 3 sides and I'm trying to find an angle. What am I going to do? It can be any of them, right? So it's going to be my, choose one, Bongo. Cos. Okay, so it's going to be cos of EZO is equal to adjacent, so OZ over hypotenuse EZ. OZ was what? I'll go look it up now. 8,74. EZ we just calculated as 10,07. I want the angle, therefore I'm going to take my cos over, take the shift cos, and get the answer. So the angle that Zora has to throw the shoe back at Erin is at 29,78 degrees. And grade 10s, that is as complicated as I'm going to make it this year. So I'll take a picture of both of these. The video will go up as well if you want to refer to it again. Otherwise, I will see you in just over a week's time.